Welcome to this explainer. Today, we're on an absolute mission to capture the essentials of Daniel Drescher's definitive 25-step guide to blockchain, and we're going to do it in 8 minutes or less. I know, it sounds like a tall order, but we're going to break down this revolutionary technology step by step. That way, you can really grasp the fundamental concepts without getting bogged down in all the technical weeds.
So, let's dive right into our source material. Daniel Drescher's Blockchain Basics promises something incredibly rare. It explains the complex, under-the-hood machinery of blockchain without requiring any intimidating mathematical jargon. Seriously, no advanced math degree required. It's all about clear concepts and helpful metaphors, which is exactly how we're going to approach it today.
Now, the crucial puzzle we're trying to solve today is right here. How do you actually achieve trust in a system where literally no one knows each other? Think about it. In the physical world, we use banks, lawyers, and government registries to establish trust. But in the digital world, figuring out how to herd a group of completely independent, anonymous computers in a totally trustless environment is the core puzzle of blockchain.
Section 1. The Big Picture.
Well, to understand the solution to that puzzle, we first need to look at the big picture of software architecture and how these systems are fundamentally built. On one side, we have centralized systems. Think of a traditional bank where everything relies on a single central point of control. But on the other side, we're moving away from that and stepping into distributed systems. This is a network of connected components where everyone shares the load and there is absolutely no central boss in charge of the data.
Now, this is where Drescher uses this brilliant little grammar trick for understanding software, the verb versus adverb rule. See, the functional aspects of a system, what it actually does, like sending a message or taking a photo, are the verbs. But the non-functional aspects, how securely, quickly, or reliably it does it, are the adverbs. Blockchain is actually the adverb engine. Its entire purpose is to securely maintain the integrity of a distributed system.
Section 2. The double spending problem.
So how does this architecture prevent digital fraud? Imagine trying to counterfeit digital cash. In a distributed network, updates across all the different computers take a little bit of time. Because of this, a bad actor could theoretically exploit this time delay to transfer the exact same digital asset, like a digital coin or even a digital house, to two different people simultaneously right before the network catches up. That's known as the double spending problem.
To stop this kind of digital counterfeiting dead in its tracks, we have to undeniably prove ownership. Drescher outlines these 3 foundational steps to do just that. Step 1. Identify the owner. Step 2. Identify the object. And step 3, map the owner to the object using a ledger. By doing this, we're essentially creating this unchangeable digital witness that securely links a person directly to their property.
Section 3. The unchangeable data store. Okay, so how do we actually build this thing? I love the metaphor used here. Think of a traditional ledger as a bound book. It has a fixed spine, but it's vulnerable, right? Someone could secretly tear a single page out. Now imagine physically tearing the spine off that book and replacing it with an ordering catalog of loose pages. In this catalog, every single page is securely linked to the exact page before it using mathematical reference numbers.
So, these mathematical pointers, they're called hash values. You can think of them as basically cryptographic digital fingerprints. If even a single letter of transaction data on a page is altered, the fingerprint changes entirely and the whole system instantly detects the tampering. It locks every single transaction perfectly in place. And this really highlights the whole all-or-nothing approach of blockchain compared to your standard traditional database. In a normal database, hackers can secretly edit past entries. But because of those interlocking hash values in a blockchain, you literally can't secretly change history without having to painfully recalculate and rewrite every single block that comes after it. It makes tampering practically impossible.
Section 4. Reaching distributed consensus.
All right. The data is secure, but how on earth do we coordinate all these independent computers to agree on one true history when there's no boss telling them what to do? Well, it requires a purely distributed peer-to-peer setup. These independent nodes constantly chatter in a gossip-style network. When a new transaction happens, they gossip about it, sharing and verifying the latest transaction blocks with their neighbors until the whole network is totally updated. But wait, to stop bad actors from just spamming the network with fake histories, the system introduces a sort of toll fee. We call it the hash puzzle. It's a really computationally expensive math problem. The system essentially forces computers to spend real computing power and energy to solve this puzzle, just to earn the right to add a new block to the chain.
And that brings us to a really fascinating realization. As the quote says, the blockchain acts as a continuous voting scheme. By choosing to spend their computing power to build on a specific chain, the computers are actually casting a vote. The longest chain with the most computational work backing it becomes the trusted, authoritative history through this continuous, democratic vote by the computers.
Section 5. Overcoming blockchain limitations.
Now, because every single computer in this network has to verify everything transparently, we inevitably hit some roadblocks. We face conflicting goals here: transparency versus privacy, and security versus processing speed. This is exactly why we're now seeing the emergence of new, hybrid blockchains that attempt to balance these competing forces for real-world commercial use.
Which leaves us with a pretty profound final thought. As we strip away the need for traditional banks, brokers, and middlemen, how does society change when trust itself is no longer based on human relationships, but is fully automated by unfeeling code? It makes trust a mere commodity. And that is a massive paradigm shift for how we manage ownership and interact globally.
And there you have it. We've covered the core machinery of how trust is engineered in a trustless world. If you enjoyed this, subscribe to In 8 Minutes and never miss what matters.